In this video, we're going to look at a 2017 past paper question, and it's about the Gibbs free energy equation, and it's quite an interesting question in that it's linked to a graph. So if I read the question, it says this question is about free energy changes, enthalpy changes and temperature, and the Gibbs equation is shown below. A chemist investigates a reaction to determine how delta G varies with temperature. The results are shown in figure 18.1 and we have a graph here. Then it says what is significant about the gradient of the line and the values P and Q shown in figure 18.1. Explain your reasoning. So the first thing to notice is that this is a straight line graph. So there will be a link to the equation for a straight line, which is y equals mx plus c. And we have to figure out which bits of this Gibbs equation relate to which bits in this straight line equation. So if we look at this graph, we can see the y-axis is delta G, so that must be y, whereas the x-axis is temperature, so that must be x. And if we look here, to figure out which is M and C, the two things we have left are enthalpy change and entropy change. And to figure out which is which, if you look here, we've got two things times together. So this must be the mx term. Now we already have x as T, temperature, so M must therefore be delta S, entropy change. And that means that C must be what's left, which is enthalpy change delta H. So if we start answering the question then, so the first mark is for relating the Gibbs equation to this y equals mx plus c equation. And then the second mark is for specifying that the gradient is delta S, the change in entropy, and we need that negative sign. Our third mark comes from identifying this point P, the y-intercept, as delta H. And our last mark comes from identifying the importance or the significance of this point Q here. So if we look at Q, it's a point on the x-axis, and the x-axis is temperature. And if we go across to the y-axis, it's a temperature at which delta G Gibbs is 0. So therefore that point Q must be the temperature at which delta G is 0. So in other words, the temperature at which the reaction becomes just about feasible. Or we could alternatively say the temperature at which the feasibility changes. I hope you found that video helpful. If you did, please like and subscribe.